A shelf of books, sorted by price. 15 pairs to check, or 3. So what actually changes? Pattern 1 of 10 in the NBX STUDIO dojo. 2 pointers. It's the one that turns a nested loop into a single walk, as long as the data is sorted. Before any code, learn to read the question, because problems announce their own pattern if you know the words. When the input is already sorted, somebody put that ordering there deliberately. When you're asked for a pair, exactly 2 things. When those 2 must add to a target. And when it says palindrome, which is the same idea, wearing a different coat. But if the array is not sorted, none of this holds, and that's a hashmap problem instead. 2 of those signals in 1 sentence, and you can stop reading. Read the question before you read the array, and half the work is already done. Here's the version everybody writes first, and there's nothing shameful about it. Pair every number with every other number and check the total. For 6 items, that's 15 pairs, fine. For 1,000 items, it's 500,000. For 1,000,000, it's 500 billion, and your interview is over before the program is. The 2-pointer version checks 3 pairs on that same 6-item list, 1,000 on the 1,000 and 1,000,000 on the 1,000,000. That gap isn't a micro-optimization, which is why interviewers keep asking it. Picture a shelf in a bookshop, already sorted by price. £1, 3, 5, 7, 9, and 11. You've got a gift card for exactly 12, and you need 2 books that total it, no change given. The obvious move is to check every pair. 1 and 3, 1 and 5, 1 and 7, and so on, all the way around. 15 combinations for 6 books. It works, and on a shelf this size, you'd never notice the cost. But hold on to that number, 15, because we're about to make it 3. Here's the smarter move, and it starts before any comparison at all. You stand at the cheap end of the shelf, and a friend stands at the expensive end. Left equals 0 puts you at the first position, holding the £1 book, so left is 0. Then right equals len of nums minus 1 puts your friend at the far end on the 11, so right is 5. That minus 1 catches people out constantly. Len of nums tells you how many books there are, which is 6, but positions start counting at 0, so the last one is 5, not 6. Nothing has been compared yet. All we've done is decide where to stand. While left is less than right just means carry on until the 2 of you bump into each other, because once you've met, there's nothing left that you haven't already considered. Then current equals nums of left plus nums of right, which is a formal way of saying add up the 2 books you're each holding. That's £1 plus £11, so current is 12. And the first thing we check is whether current equals target. It does, first comparison, and that wasn't luck. The shelf being sorted is what let us start at the 2 extremes, and the extremes are where the biggest and smallest totals live. Quick one, and it's from the dojo itself. We're holding £1 and £11. That totals 12, and 12 is exactly the gift card. So, what happens now? Do we keep looking for more pairs? Do we tell the friend to pick something cheaper? Are we done, and we hand back the answer? Or do we start again from the beginning? Have a think, and pause the video here if you'd like a moment longer. Ready? We're done. The question asked for a pair, we have 1, and carrying on gains nothing. Return left comma right hands back the 2 positions, 0 and 5, rather than the prices themselves, because that's what the question asked for, and it's what an interviewer expects. 1 pair, out of 15. That was a friendly example though, with the answer sitting at the 2 ends. So let's make it hard, because what matters is how a pattern behaves when the guess is wrong. Same shelf, but the gift card is only £8 now. You're still holding 1, your friend is still holding 11, so current is 12, and we're £4 over. Somebody has to change book, and this is the question the entire pattern turns on. Think it through with me. If you, on the cheap end, reach for something pricier, the total can only go up, and we're already too high. So L if current is less than target is the branch we did not take this time. We fall through to else, which is the too big case, and the only person who can bring the total down is your friend. Right minus equals 1 moves your friend 1 place to the left, so they put the 11 back and pick up 9. New total. 1 plus 9 is 10. Still over budget, so nothing is solved yet. But look what that single step quietly bought us. Every pair involving the £11 book has just gone. All 5 of them. And we never looked at 1. We didn't need to. The shelf is sorted, so if 11 was too dear beside the cheapest book, it's too dear beside every book. That is the trick, the rest is bookkeeping. Your turn again, and this one separates memorizing from understanding. 1 plus 9 is 10, and the budget is still 8. So, what happens next? Do you pick a pricier book, moving the left pointer right? Does your friend go cheaper again, moving the right pointer left? Do you both move at once? Or is there simply no answer? Have a think and pause here if you want longer. Ready? Your friend goes cheaper again because the total is still too big. Same rule as last time, and it will be the same rule every time. So your friend steps down once more, putting back the 9 and picking up 7. 1 plus 7 is 8, the budget exactly, and we return the 2 positions again. Count what we actually did. 3 comparisons on a shelf where checking every pair would have been 15. And the number that matters isn't 3, it's the shape of it. Every single turn of that loop threw away a book for good, which means the work rose in step with the shelf instead of exploding. Double the books and you roughly double the checks. That is what big O of N means, and it's why this survives a million books when the obvious version doesn't. Here's the entire pattern on one card, and it costs big O of N in time and big O of 1 in space, because 2 integers is the whole of the extra memory it ever needs. Total too small? You move up, because you're the only one who can add value. Total too big? Your friend moves down, because they're the only one who can take it away. And if they meet without ever hitting the target, no such pair exists, and an empty list is the right answer rather than a failure. This pattern is worth real effort, because it isn't one problem, it's 4. 2 sum 2 is what we just wrote. Valid palindrome compares the 2 letters and walks in. 3 sum fixes 1 number and 2 pointers the rest. And container with most water moves whichever wall is shorter. Do all for this week. 3 things to take with you. The signal is a sorted input and a question about a pair. The move is to start at both ends and let the total tell you which side steps. And every step throws away work you never have to do. Next in the dojo is sliding window, for when the question stops asking about a pair and starts asking about a stretch. Go and do 2 sum 2 now, while the shelf is still in your head.